Section 1.4 is on integer exponents and scientific notation. So the first thing we're going to discuss is a set of rules that comes with integer exponents. So the first rule we want to look at is if x is any non-zero real number and n is an integer, then x to the negative n equals 1 over x to the n. So remember, we can always write a denominator of 1 if there's no denominator written. And so what this rule says is anything to this negative n power, we can flip it across the fraction bar to make it positive. And so a negative exponent flips or moves whatever it's attached to. So let's go ahead and try this with example number 1. So we have a negative 5 in the exponent, and so we want to make sure that we flip the 2 that's attached to it across the fraction bar. So we can flip the entire thing to the bottom. So this becomes 1 over 2 to the positive 5. And then we can evaluate 2 to the 5th. So this becomes 1 over 32. Now you want to be careful with negative exponents, because sometimes people will mistakenly do 2 to the negative 5th, and then they just make this negative 32, which is not correct. You want to make sure that you flip it first and then evaluate the exponent. So let's try the next one, w to the negative 6. So again, we can flip the w that's attached to this negative 6 exponent, and we're going to flip it to the bottom. So this becomes 1 over w to the positive 6. Now let's go ahead and do one more. We have 2/3 to the negative 4. So we have a negative 4, and we're going to want to flip it over the fraction line. So that's 1 over 2/3 to the positive 4. And so let's go ahead and write out this denominator so we can simplify it. Well, 2/3 to the 4th means I have 2/3 times 2/3 times 2/3 times 2/3. And so remember, when we multiply fractions, we multiply across the top and across the bottom. So we have 2 times 2 times 2 times 2, which is just 16. And on the denominator part, we have 3 times 3 times 3 times 3, which is 81. And so we need to fix this a little bit because it's a complex fraction. And so we're going to use keep, change, flip to do that. So we're going to keep the top as 1, and then we're going to flip the bottom. So we have 81 over 16. And 81 over 16 times 1 is just 81 over 16. Let's look at the next rule. If x is a real number and n and m are integers, then x to the m times x to the n is equal to x to the m plus n. So this is saying when you multiply with a common base, you multiply the coefficients and you add the exponents. So let's try this with example number 2. We have 4 to the 3 times 4 to the 10. And so because we have the same base, a base of 4, we can just add the exponents. And so we have 4 to the 3 plus 10, but that just ends up being 4 to the 13th. And we can leave this in exponential form. What about y times y to the 6 times y cubed? So remember that if there's no exponent written, that's just an exponent of 1. And so again, we have the same base. We have a base of y. And so we can just add the exponents together. So y to the 1 plus 6 plus 3, which is just y to the 10th. And the third one. So 5x squared y, and then negative 2xy cubed. So I'm just going to write the exponents that we're missing on the first y and the second x. We are going to multiply the 5 and the negative 2 together. And then we're going to look at the x's, and we're going to look at the y's. So we have 5 times negative 2. And then we're going to add the exponents on the x's and then on the y's. So x to the 2 plus 1 and y to the 1 plus 3. And so we end up with negative 10 x cubed y to the 4th. Rule 1.7 says that if x is a non-zero number and n and m are integers, then x to the m over x to the n is equal to x to the m minus n. So this says that when you divide with a common base, you divide the coefficients and you subtract the exponents. You subtract the denominator from the numerator. So let's try this with example number 3. So again, we're looking for the same base. We have x to the 12 over x cubed. So we have the same base of x's, and then we just want to subtract. So x to the 12 minus 3, which is just x to the 9th. And for the second one, we have y cubed over y to the 20th. And we've got that common base of y. And we do y cubed minus 20. But that's y to the negative 17. And we don't like to have negative exponents. And so we're going to use that first rule that we learned. And we're going to flip this to the bottom to make it positive. And so we end up with 1 over y to the positive 17. Rule 1.8 says that for any non-zero real number x, x to the 0 is equal to 1. And so that just says that anything to the 0 power is 1. So looking at example number 4, we know that x to the 0 power is going to turn into a 1, but that 3 is still out front, so we have 3 times 1, which is just 3. Let's look at the second one. It's a little bit more in depth. So we have negative 2x to the negative 5, and then y cubed to the 0. So this y cubed to the 0 is going to turn into 1. So let's just rewrite that really quick. We have negative 2x to the negative 5, and then times 1. Well, that negative exponent is going to move the x. So this negative 5 is going to move the x to the bottom, and the negative 2 is going to stay right on the top. So we have negative 2 over x to the positive 5. Example number 5 says to divide and then simplify your answer. So we're going to look at the numbers, the x's, and the y's separately. So we have 3 and 27 we'll look at. We've got x to the negative 5 and x squared. And we've got y to the negative 6 and y to the negative 8. Now there's a few different ways you can approach this problem, and so it doesn't matter which way you do it as long as you get the right answer. So I will show you both ways just so you know. So looking at 3 over 27, that's going to simplify to be 1 over 9. Then let's look at x's. We have x to the negative 5 over x squared. So I'm going to use the subtraction rule here. That's x to the negative 5 minus 2, which is x to the negative 7. And then we need to use the negative exponent rule to make it positive. And so this ends up becoming 1 over x to the positive 7. So we have y to the negative 6 over y to the negative 8. And so I'm going to use the subtraction rule again. We have y to the negative 6 minus negative 8. And so this ends up becoming 2 positives. And we get y to the negative 6 plus 8, which gives me y squared. And I'm just going to write this over 1 so we can see where everything is falling at in the fraction. So now we just need to put everything together. So on the tops of our fractions, we have a 1, and a y squared. And this is all multiplication, so 1 times y squared is y squared. And on the bottom of our fractions, we have 9, x to the 7th, and 1. And so we end up with 9x to the 7th. And so that's one way to do it. We also could have used the negative exponent rule to begin with. So let's go ahead and flip the letters that need to be flipped first. So let me go ahead and rewrite this. So anything with a negative exponent needs to be flipped across the fraction bar. So x to the negative 5, that's going to get flipped down. Y to the negative 6 is going to get flipped down. And y to the negative 8 is going to get flipped across to the top. So we have 3, and then y to the 8th goes to the top. And then on the bottom, we have 27, the x squared that was originally there. X to the 5th got moved to the bottom, and so did y to the 6th. And so we're going to use the same rules. We've got 3 over 27. We have on the denominator, we have x squared and x to the 5th, so we can actually add these together. And then as far as the y's go, we have one on the top and one on the bottom. That's y to the 8 minus 6. And so 3 and 27 can be simplified. That's 1 and 9. And then we have x to the 7th, and then we have y squared. And so we just need to put the y squared on the top, and on the bottom we have 9x to the 7th, which is the exact same thing that we got with the other way. Rule 1.9 says that if x and y are any real numbers and n and m are integers, then x to the m raised to the n is just x to the m times n. If we have xy raised to the n, then that means that x gets the n power and so does y, so we distribute it to both pieces. And then if I have a fraction x over y raised to the n, then we distribute it to both pieces as well, and we get x to the n over y to the n, if y is not equal to 0. So when you raise anything to a power or an exponent, you multiply every single exponent with that power. So looking at example number 6, we have 3xy squared to the 4th. So every single piece is going to get a 4th power. And so we have 3 to the 4th, we have x to the 4th, and we have y squared to the 4th. Well, 3 to the 4th is 81. We have x to the 4th. And then with our y squared to the 4th, we go back to rule 1.9, the first part, and it says that if I have something raised to a power, then I need to multiply the powers together. So we really have y to the 2 times 4. And so our final answer is 81x to the 4th, y to the 8th. Let's look at the second one. So there's a few different ways you can approach this problem. You could simplify the inside portion first and then distribute the 3 to all the pieces, or you can distribute the 3 to all the pieces first and then simplify. Either way should get you the correct answer. So I'm just going to distribute the 3 to each piece. So we have 2 cubed. We've got a squared cubed and b cubed cubed. And then on the bottom we have 3 cubed. We have a cubed and then b to the 4th cubed. So let's simplify a little bit. We've got 2 cubed, which is 8. And then power to a power for the a gives me a to the 2 times 3, which is 6. And then b to the 9th, since we've got 3 times 3. And on the bottom, we've got 3 cubed, which is 27. A cubed. And then b to the 12th. But now we need to simplify. Now we can't simplify 8 and 27, but we can simplify the a to the 6 and the a cubed, and the b to the 9th and the b to the 12th. So we have 8 over 27. And then we have a to the 6 minus 3. And b to the 9 minus 12. And so we get a cubed, and I'm going to write this over 1, and then b to the negative 3. And so we just got to make sure that we move that b to the bottom to get the final answer. On the top we end up with an 8 and an a cubed, and on the bottom we end up with a 27 and a b cubed. And that's your final answer. And for the third one, we've got 2a squared b to the negative 3, c to the 0, raised to the negative 4 power. So before we start distributing, let's just take a quick look here. We have c to the 0. Well, we know that this ends up becoming a 1. So we don't really need to worry about this piece. And now I'm going to show you how to deal with a negative exponent. You could distribute and then flip at the end, but there is another way we can do this. So we can write negative 4 as negative 1 times 4. And so what this means, this negative 1 means that we can flip the entire fraction and then raise it to the 4th power. So what that means is I'm now going to have 1 over 2a squared b to the negative 3. So I flipped this first, and this is going to be raised to the 4th power. So we just took the negative and flipped it, and now we're going to distribute the 4. So everything's going to get the 4th power. So on the top we have 1 to the 4th, which is just 1. And on the bottom we have 2 to the 4th. We have a squared to the 4th and b to the negative 3 to the 4th. Well, this ends up being 1 over 2 to the 4th, which is 16. We get a to the 8th and then b to the negative 12. And the last step is to move the negative power up. We end up with b to the 12th over 16 a to the 8th. And let's just talk a little bit about scientific notation. So a positive number written in scientific notation has the form a times 10 to the n, where 1 is less than or equal to a, which is less than 10, and n is an integer. So one more rule for you guys to memorize is Rule 1.11, which is how we convert decimal notation into scientific notation. So we'll move the decimal point from its original position to the right of the first non-zero digit. You'll count the number of places that you moved the decimal point. This number is the absolute value of the power of 10, or just the exponent. Now, if you move the decimal point to the right, then the exponent is negative. If you moved it to the left, then the exponent is positive. So let's try this with example number 7. We have 7,816. So if you don't see a decimal point written, it's because it's at the end of the number. The goal is to put it between the 7 and 8. It's to the right of the first non-zero digit. So starting with our original, this one in blue, we need to move it to the orange spot. So we're going to move it 1, 2, 3 spots. So we're going to write 7.816 times 10. Is that going to be to the positive 3 or the negative 3? Well, it's going to be to the positive 3 because I moved it to the left. And so in scientific notation, it's 7.816 times 10 to the third. Let's try the next one. We've got 15,200,000. So we have our decimal at the back. And the goal is to put it to the right of the first non-zero digit, which is the 1. So we need to move it 1, 2, 3, 4, 5, 6, 7 spots. So we have 1.52 times 10 to the positive 7 or negative 7. It's going to be a positive 7 because, again, I moved it to the left. And for the third one, we're given the decimal point this time, and we want to move it to the right of the first non-zero digit, which is the 4. So I'm going to move it 1, 2, 3, 4 units. So we have 4.6 times 10. This time I move to the right, so that's going to be a negative 4. So 4.6 times 10 to the negative 4. And for the last example, we're going to just go the opposite direction. We're going to write it in decimal form instead of scientific. So we have 8.8632 times 10 to the 4th. So I'm just going to rewrite my number. And because it's a positive 4, we kind of want to think in the opposite direction. If I have a positive number, we're going to move it to the right. And if I have a negative number, we're going to move it to the left. It's kind of the opposite of the rules that we're given. So because I have a positive 4, I'm going to move it 4 spots to the right. 1, 2, 3, 4. And so my new number is 88,632. Let's try the second one. We've got 6.032 times 10 to the negative 2. So we want to move it 2 spots to the left. 1 and 2. If we have any empty little circles, half circles here, we just filled it with a 0. And so in decimal form, this becomes 0.06032. And the last one. We've got 4.4861 times 10 to the negative 5. So we're going to move this 5 spots to the left. 1, 2, 3, 4, 5. And then fill in the zeros that are needed. So this becomes 0.000044861.